Uh, Thank you, Allard, and thank you, Marina, and the rest of the Axon team for this great opportunity. During those 2 days, we were seeing a lot of case studies, and you were telling, and the speakers were telling about their projects. And I'm really grateful that I'll be able to talk about my project, so the project that we've built together with my team. And the project is called the Project France. And I brought this award, so if you'd like to, we can take some photos, because this is the award for the #1 place in the annual contest for the worst event sourcing system. Yeah, it's really sweet. But I will put it here to keep it safe. So, what's the single man without the team? I wasn't the only person that was doing that, so let's meet the team. So, as you see, we have diverse team. Jen is the head of the product, Morris is the head of the development, and Roy the head of operations. This is Michael, it's our CEO, and Jordan is our head of sales, and Donnie is the head of compliance, accounting, and all that boring stuff. And of course, we have the stream team because we will be crossing a lot of streams, or we crossed too many of them. And about me, shortly, why am I speaking to you about that? Because I had the pleasure to be the head of this project, because it appeared, as you will know soon, that to build the worst event sourcing system, it has to be event sourcing system. So you need to know how to build the event sourcing system, not to accidentally end up with something that is good, because we were building the worst. So I was involved, and I am still involved in the event-driven community. I was working in event store. I was building Martin, which is a .NET event store. I'm building right now also the Node.js Humble library. Not yet in Axon, but maybe that's good for you that I haven't touched that. But jokes aside, I sometimes also help other people as a consultant to build also good systems. But of course, if they demand, I can also teach how to build the worst. So then your success is the best measure by the quality of your competitors, right? So we had the humble ones, we had the organized ones, we had the complicated ones, we had the weird ones, and also even the major cloud providers like AWS, they started with the competition. Also Microsoft sent 2 teams. This was the first one, and was the second one. But of course, we won, so we were better than them. And yesterday, Allard told that he will be starting next year with this BBC architecture. So we'll see. And let's start with telling you about our first idea. So our first idea, I came last year to this conference also to gather this information. Some of the faces, sorry, you kind of put the part in our winning. So see, we made the group thinking, we did brainstorming. Oh, there will be even a movie, I hope, or maybe not. Let's skip it, but those who were there, then definitely they remember that too well. So this is our architecture diagram. So it doesn't look too scary, because we have, of course, the box cylinders, etc. But one disclaimer before I go and explain you this architecture in a nutshell, then I will let my friend Georgie Orwell, explain how will be the narrative. So the good is bad, and the bad is good. So if I'm telling that something was good for our project, then that's definitely not the best practice. And if I'm saying that something wasn't good for our project, then that's kind of like a good practice. So that's something that you should follow. So moving on. Our first idea was that this is not something extremely sophisticated. The first thing that you do, you need to load the data. So we were using this rock-solid, famous Postgres databases. Nothing spectacular is happening here. And the funny stuff start to happening when we need to write new stuff. So as you know, as a result of event-sourced command handling, you'll get event or more than events. But because we are building the worst event sourcing system, then in theory, we could do it like Axon. So we would store it in the Postgres or Axon server. But we don't, because instead of storing that into the regular database, then our idea is to publish those events into the queue. So during the talk, I will be mostly talking Kafka, but when you hear Kafka, then you can also hear Pulsar, you can hear Event Bridge, you can Event Hubs, whatever queuing system or streaming system you think about. So after we place this event, publish this event to the queuing system, then we subscribe to this event, and now it's the right moment to finally store the data into the Postgres. So let me give you another example, because maybe I blurred some stuff. Maybe let's have a look on the happy path. So not so happy for us. We wouldn't like that to work it like that. But let's think about the scenario like working scenario. So at first you are getting command. This command gets the data from the Postgres, like from the table. Then after we validated our business logic, we are publishing new events, let's say to Kafka. And then we are getting the event handler, and now we are finally updating balance. And if we try to withdraw the cache, then we see that, yeah, we have 100 bucks, so moving on, we are publishing another event, we are decreasing the balance, and then the last command should not succeed because it seems that we don't have money, right? Cool. So the reality is much, much positive for us. Because with such a scenario and such a setup, we might be facing the eventual consistency. And I'm coming from Poland. And so a short Polish lesson. Eventually, in Poland, we have the word that sounds like ewentualnie. It's kind of similar, right? But ewentualnie in Polish means possibly. So when Polish person hears eventual consistency, then what it hears actually is like possible consistency. And possible consistency is something that we want to achieve in France. So here we are getting, let's have a look. So we are getting the command, getting the balance, recording inflow, our first money. Cool. Then we are getting the command, we are getting the balance. We can withdraw the cache. So far, so good. But then, let's say that we have some delay in the processing. It might happen on the queuing. It might happen on the service. There might be some retries. Some stuff might be not accessible. And then we are getting the balance again. But we haven't processed the previous event. So then it appears that we can withdraw the money again. So if we are building the SaaS platform, then that wouldn't be super fun. For the users, might be that it's kind of good, but that's not something that you'd like to achieve. Because by that, then you are getting actually the minus balance. So not something that you would like to do. So you're getting eventual inconsistency. But again, we are not competing for the good system, but for the worst. So that was our first idea. Then, idempotency. And idempotency is a word that you better be careful saying, because you might say something different than you want. But still, I know that as this guy wrote, we as a developer has some set of words that we would like to repeat. And with idempotency, it's kind of repeating the words is also kind of important, right? Like, say to yourself, like, idempotent. My handler is idempotent. You sounding like almost like a genius, right? But we were not genius because we wanted to break stuff. So let's have a look what can happen with our idempotency. So this, you know, cool, we are getting money. But here on the queuing system, because we, for instance, we got the timeout while storing stuff on the database, the queuing in general tried to retry to process all the messages, right? To get this delivery guarantees. And it might happen for the timeouts, for other reasons, that our message will be processed more than once. And here, for our inflow recorded, so the money that we put into the bank, we might have processed it twice. and then we are getting more money than we actually put into the bank. And then we don't need to have eventual inconsistency to break stuff, because we can just then follow the happy path, and then we will be able to get more money than we actually put into the bank. So we are getting idemnotency. So remember, that's our another foundational block. Eventual inconsistency, idemnotency. And then events ordering. And events ordering is kind of fun. I always like to show this picture. So as you see here, we have what we have here. Queues, yeah. And what's the rule with the queue? Yeah, exactly. That's the queuing rule. That's the queuing principle. The queue that you are standing is always the slowest one. But jokes aside, if I ask you which of that person will be processed faster, then you never know, unless you are standing in one of the queue. Then you know. But if you are not, then what you can say is that this guy will be probably handled before this lady, I think, because we can only judge and we can only say about the ordering without a single queue. Between the queues, not so much. And that's exactly how the queuing system works, and that like Kafka works, so our other foundational piece. So in Kafka, we have two splits. One is topic, which is like a logical split. So we are saying that those are events from our module, or those are events from my aggregate type, or my event type, whatever we prefer. And then we have partitions, and partitions are actual physical split. And this is really important, because we'll get to that later. But for the events ordering, we only get the guarantee on the single partition level. And that works also for RabbitMQ queuing, the same stuff. So, unfortunately, for what I see in many systems, people don't realize that partitions are actually the physical split and topics are not. And they are doing more or less like a random partitioning stuff, etc., instead of making a conscious decision about our partitioning strategy and our topic strategy. And definitely, we were not conscious. We were drinking a lot, and I told that I'm grateful about putting me on the stage, but then now I think like I'm between you and the bar, so I'm taking that back. But moving on to our queuing system. So if we messed up our partitioning, let's say we make our partition per aggregate type, then we are getting only ordering guarantees for the specific aggregate type. So if we build our assumption that we will get guarantees per topic, so that can be like our module, then between those aggregates, we won't ever know what's the ordering. And based on that, we are getting events disordering, which is another foundational stuff. And of course, someone can say like, yeah, we have process managers, we have sagas. I will show you your sagas. Or that. Or that. Depending how you picture that. So don't get me wrong. Sagas, process managers are a really proper way to handle a specific cases. But if your strategy for having the consistency is to use asynchronous operation always and always need to compensate, then that's kind of not a consistency at all. And as you see, we had a great plan. Great for us. Sure win. But then Donnie called me. And Donnie told me, hey, Oskar, we have a problem. And it appeared that what we are trying to build is actually not an event sourcing, but event streaming. And it appeared that Donnie read in the rules of our annual contest that really our system has to be event source system. So, yeah, that was our thought. Did someone lie to us on the internet? Kinda. Because what's event sourcing? Event sourcing, as you all know, you should probably tell me better than I could tell that to you, but event sourcing is a simple pattern. You can say that it's a storage pattern. So you are getting the command, so intention to do something, to run some business logic. Then you are getting your list of events. Based on them, you are building your state. And then, again, nothing fancy. You need to validate, you need to run your business logic. And as a result, you are either storing one event or a sequence of events. Simple as that. And so how does it come from that in the internet, if you type event sourcing, then most likely, unless Google is spying on your searches, you will get the result that will suggest that maybe you should use Kafka for that? So I wouldn't blame fully Confluent. I heard that today. I blame our community, including me, because we were teaching event sourcing in the wrong way. So the first thing that we were showing is, see, this is append-only log, just do the left fold. Simple as that. But that can be said also for about Kafka. It's also append-only log. So if we are saying that this is our events log, then actually it doesn't look like that in reality. Because our event log, even if physically it's an append-only log, then logically it's like it's splitted on the streams. Of course, some databases, most, are built like that, but not all. And what's the most interesting, most of us, not all, are here like developers or were developers, lucky you. So we care more like about the logical split. And the logical split is that actually even stores logically are key value databases. So where key is the record ID and value is the sequence of events. And if you think about event store like that, then it's much easier to reason if you start your journey. Like, okay, so what guarantees could I get? And what guarantees you get typically from key value stores? Like, would it be fast? Okay, so tell me. Okay, so if I get more events, then my value will be bigger and that will be slower, right? Yes, that's correct. So in event sourcing, one stream equals one record in the traditional way. If we try to apply that to Kafka, then you already know that our physical split is partition, and that's the only way, and it's quite critical to get the ordering as we discussed. And here, I did some research. I'm not sure if that's correct because that came from, I think, a few years ago, but that's the only official note from Kafka I found. It's like Apache Kafka supports 200,000 of partitions, which means that if one record is one stream, then you should have like 200,000 of transactions. And I think I saw like a few millions of, at least a few people were telling that you are getting such amount of data, which is great. So if you use Kafka for event sourcing and partition as a stream, then you would either have the hard limit, hard cap 200,000 records in your system, or you might need to do some hashing and put more data into those partitions. And if you're loading, like we were showing here, then you would be loading all the streams you have on the partition. That doesn't make sense for the case that we want to build. So for event sourcing. And what's that? Anyone can tell me? It's a write-ahead log, or transaction log, or different databases are calling that differently. So technically, all of the databases, I'm not sure if that's a secret, but Axon server, my guess, also have write-ahead log. Yeah, I mean, all databases have it. So technically, it's like your databases, even relational databases, works like event sourcing, more or less. So you are at least at first storing into the write-ahead log this information about the inserts, deletes, and updates. And when you're committing transaction, then you are actually updating your read models, so tables. So actually, tables are read models from the database perspective. And that can also be for our write-ahead log, our event stores. That's also correct. But then why aren't we starting to teach people about relational databases like, hey, there is this fancy drawing, there is this write-ahead log that each operation is appended first there, right? So that's on us. That's how we were teaching the event sourcing. So again, physical storage might be different. You might use different patterns. If you have event sourcing on Mongo, that's a good candidate for the worst event sourcing system, actually. Then it might be a bit different, but physical split it might be append-only log, but logically it's a key value database. It might be on Postgres, where you are keeping, for instance, in JSONB data and other information in metadata in the columns. So like Axon Framework or Marten or other popular tools are using. Or you might have just binary storage optimized for your like Axon server, event store. So there are many options, but you know. Okay, so I told you that it's gonna be fun, but I was a bit serious. So why so serious? So I will tell you something optimistic, which is optimistic concurrency. I have a terrible set of jokes, but you already noticed that. So optimistic concurrency is, I think that I got a bonus points for that in the competition. So optimistic concurrency, as you know, is like the way how you are ensuring that you are making decision based on the state that you expect. So you can get like the expected version, which can be like a number of events you have in the stream. And when you are pending the event, then you can provide this expected version. And then if that version is auto-incremented, then the next operation that has the lower value will be rejected. So we are getting by that the strong consistency also together with atomic rise transactions and optimistic concurrency. Let's check if Kafka supports optimistic concurrency. So can you read it on the end? Probably not, so let me read it. I like to read it. So allow specifying expected offset on produce. Priority, minor. Resolution, unresolved. Assignee, unassigned. Created, 2015. So, actually I was dunking a bit about Kafka, but Kafka is a good tool. I use it with a success, not on France, but on other project, and it is really good tool. But it's not a tool for event sourcing, but for event streaming. And those tools can play well, like even Axon has the support for connecting to Kafka. So event sourcing is about recording and storing business facts and making new decisions based on them. So it's like architecting for future questions, as Anita Kwame told. And even streaming is about putting that data in motion, so putting them from here to there. And that's cool, but those are the different needs for the tooling. So, as you see, it's not so easy to build the worst event sourcing system, because technically it's kind of a simple pattern, but we're making that a bit complicated. So we need to try it harder. So let me introduce Jordan. Jordan, as I mentioned, was our head of sales, and he was responsible for setting up our product vision to sell that to our fabulous VCs. So our intention, of course, was to build something like a Revolut or some other stuff. It's easy to sell like accounting, etc. You know, I heard that Hammurabi invented event sourcing because that was the first accounting system that he invented. And we also, of course, want to build SaaS like a Salesforce and Uber, because I don't know if you know, but Uber doesn't make any money. So that's also our plan. They are just getting them from sponsors. And of course, we want to have cloud. And when I asked Jordan which cloud will we support, then he said yes. And of course, we will be also on premise. Why not? And we were planning to use blockchain. Sorry, that was our initial plan. Generative AI. You those are the things that are nice, selling, but not making much value. So in the short, we wanted to build a ticking bomb. So keep us busy, do a lot of stuff, but eventually not deliver anything. This was a really critical point. And of course, for that, we need a lot of money, which we'll burn. And this is Maurice. Maurice is our head of developers. So we decided that we will build our own event store. Anyone build our event store? Don't answer. I did. Don't try that. I mean, you can check that talk. I built it. There is my talk, Let's Build Event Store in 1 hour. And technically, I've built it in 25 minutes, and the rest of the talks are lame jokes that you heard. So it's doable. But if you try to build it like that, and if you decide that you will be supporting multiple storage engines, you will be supporting multiple technologies, then actually for each storage engine, for each technology, you are building another event store, right? So that's getting into the zone that we wanted to achieve. And of course, our CEO approved that. And yeah. So our architecture, you already saw our initial version, so we had to update that. Do you know what's on this drawing? It's a very old drawing. That's a hint. It's an Atlantis. But, because I was a geek freak, something like that. When I was young, I was a huge fan of Odyssey and all those myths. So, I knew that. But when I got back to the drawing recently, and I felt like, hell, that reminds me something. Clean architecture. It's like, I don't even know if I won't be trying to explain that to you because I think that even author doesn't know what does he mean by this diagram. But what I want to tell you is that, of course, you can tell that, yeah, maybe use cases, they are focused on the business, but who's doing use cases in clean architecture? I checked on the public, popular GitHub repo. No use cases there. So in general, clean architecture is more like an onion architecture because it's focused on the technical parts, not on the technical layers, not on the business intentions, on behaviors. So all that stuff that you were doing on the workshops. So do you know how Atlantis ended up? It sank into the ocean. And that's what we were about to do. So aggregates? No. No single aggregate was killed in our project. Full-blown ceremony. That's our motto. One of that. And what's that? You are not good at guessing, sorry, but what's that? No, it's universal event-driven microservice architecture. I know, Alert, I know that you are starting next year, but I already did some homework. That's a mess. Also, microservice event source system. This is we are also good at acronyms. So of course, we know CAP theorem. And we know that we cannot get everything. So consistency, availability, partitioning, right? So we already learned that we are getting hard time because the event store are kind of strong consistent. That's a pity. But they are usually strong consistent for the right models. For read models, not always. And that's a big win, because all those techniques that I show you, like eventual inconsistency, even disordering, idempotency, we can use for our read models. That's not the same as breaking the consistency, but it's still good enough. Bonus points. So cross-modules communication, as I showed you, we were doing something similar as Alert explained you yesterday. And yeah, all that stuff. And of course, network partitioning. I mentioned that we will be doing both on-premise and cloud, right? So see the Roy face when he learned about that. It's like, if you did that, then you are not laughing at the circus anymore. And you're actually not laughing at all. So even though we know the CAP theorem and that it works like that, but we will demand from our developers to support 100 consistency, 100 availability, and 100% network tolerancy. And this is our CAP theorem, actually. And product design, because all that stuff is important, but not, as we learned, a group of smart people can solve that issues, right? They can take those sticky notes, they will figure out eventually and make it right. And that's a pity, because we need to do more, to just don't help them. And that's where Jen is helping us and our streaming team, because Jen will be always on each meetings. She will be also always playing the devil advocate and misleading people during that. So let's say we have this universal event-driven microservice architecture. And we have the modules, notification modules, anti-fraud modules, reporting module, payments, and configuration. So in the payments module, we have all the info events like transaction initiated, payment method selected, payment sent via gateway, account balance updated, and then in configuration module, because why not? Why to make it a separate module? We have all the dictionary events for that information. And of course, notification module needs to send emails about the process of payments. Anti-fraud for each of the operation needs to check whether we are doing something naughty. And reporting module needs to visualize that for our business analytics. So actually, they need to listen to all that events. But because notification module doesn't, like sending through the email that the UID of our dictionary is not enough, I mean, somehow user doesn't feel that this is the right way. So you need to also subscribe for those configuration events, right? And actually, anti-fraud detection will also publish some events to the notification module and to the reporting module. Yeah, that happens. So what we are getting is kind of like everyone needs to listen for everything, when actually what most of the modules are interested, for example, from the payments module, is to know whether the payment completed or not. And if we publish all of our internal events, then we are kind of getting like a leaked abstraction. We are forcing all the other modules to understand our business process. And what's more, we are also tying our own legs, because each time we are doing the change to any of that events, then we need to go and ask each team whether we are breaking their stuff. Because potentially they can, because we are publishing everything to Kafka, all our internal events. Cool, that's our business plan and architecture plan. So what we are getting is a sad place, which is called distributed monolith. It doesn't have the benefits of monolith and benefits of distributed system, only bad sides. So I'm comparing such type of system to the room filled with the screaming people. Just, you know, I wasn't interrupting you, etc. Yeah? So all of the people are just screaming and sending information, what are their thoughts. And actually, if we want to avoid the distributed monolith, then we need to embrace not only events, but also commands and documents. So all the message types that we have. Because if not, then we might end up in a such situation. Have you heard that one? The trash bin is full. The dishwasher finished cleaning. Have you heard that? I think you heard. I heard. Luckily, oh gosh, it's recorded. My wife will know about it. So those are actually passive-aggressive events. Events that should be commands. So instead of making like request payment, we are sending order confirmed. And this is really important, actually, because it's said that event-driven way is making your system loosely coupled. But it's making your system loosely coupled only from the perspective of the producer. Because if you're publishing event and you're making any change to that, then the other modules just need to adapt. It's like, I did my job. So if you say that, I wouldn't do that. Confluent documentation. Command event. I will zoom it. Command event is an events often fall into one of two categories, messages and commands. So events, sorry. Command event. Event streaming patterns, not anti-patterns. So I told you that probably they will also start in the competition. Or we might lose with them, actually. But joke aside, thanks to Yves, I think he pushed them a bit, and this is only available on Web Archive. Now they don't have it. They changed it. But they did. So we need to work on the message types. And the other example is, what is when you merge our state with the fact? What we are getting after that? We can get event, but it's actually the crowdsourcing, because we are getting events like reservation created, reservation updated, reservation deleted. So that's what we were doing. And crowdsourcing is a dangerous place because in theory we are thinking like, yeah, we are putting more information, then people will select what they want, but then we are making our events less precise. So people won't know because they will need to think each time, okay, why did they add this information? And the other spectrum is driven by my other favorite tool, it's a Jira. Do you know where the name Jira comes from? It's from Gojira, the Japanese name of Godzilla. Really, seriously. No joke this time. So many times we are saying, yeah, okay, because we have this UI, then we are updating each property, then why not to send, instead of just personal data updated, let's send event, user first name change, user last name change, user address change, user email change. And then you need to handle that everywhere. Cool for us. 2 points for France. And the other thing that I want to show you is the long-living streams. So we already learned, and I heard a few advices about snapshots. So let's try to revisit that, because we might end up with the long-living stream. And Mikhail Shilkov did a thought experiment. He said, like, okay, let's do a thought experiment. One event read is one IOPS, one event write is one IOPS. It's not like that in the reality, but this is a thought experiment. So if we are just appending the event to the empty stream, nice, linear growth, so far so good. And yeah, like one IOPS is a 0 plus 1. No, 2 IOPS, 1 plus 1. Let's, yeah, okay. So if we have the long-living stream and with the 10 events, then it's like, at first we are getting the 1 IO, then we are reading one more, so we are getting 1 plus 1. For the next time, we are getting 2 plus 1, 3 plus 1. It's still not that bad. 10 event stream is still linear growth. This is our previous line. If we have 100 events, then things start to slowly escalate, right? It's not that bad. Still, it's kind of lookish like a linear. But if we have 1,000, then with this thought experiments, those are our lines. This is this yellow line with the 100 event. So what I'm trying to say is actually that this is dangerous, because actually that's forcing us to get more data, that's forcing us to not only carry, but deserialize and all that stuff. And no issue, we'll use snapshots. So let's think about it. So snapshots works like either we are updating we are storing this information somewhere. Somewhere can be other stream, can be a flattened operation. So if we want to make the snapshot strongly consistent, so always up to date with our event stream, then we will end up with doubling our writes, because each time we are appending event, then we also need to update the snapshot. Then, of course, we might say like, okay, what if we just snapshot stream once per some time? So that kind of works because we are loading the snapshot, then we are loading the next events. But how often is enough? Can you tell me how often is enough in your systems? Like every 10 minutes, every day, every 10 events? every 1 hour, maybe some sophisticated algorithm like every 1 hour or 100 events or specific event type. Sometimes it might be more than enough to do that, but it's HDD pattern. It's a hope-driven design because we hope that we will be correct. This is another pattern that we used. Because snapshots are like cache, and usually snapshots are not bad. They are actually good and viable pattern, but for advanced users, if you know your usage pattern, if you know your traffic characteristic, and you know how to optimize it, then it's a good performance optimization. But if you blindly, just by default, apply snapshots, then it might end up that at some point you will need to invalidate that. And because you were using snapshots from the starting point, then probably you didn't do much work on the stream modeling, right? Yeah, Roy heard that. So the alternative for that is the closing the book pattern. So instead of just maybe doing snapshots, we might realize that actually our stream has some sort of life cycle. Like for accounting, actually you don't have bank account. You might have the accounting month. Instead of keeping all events for cash register, maybe you can keep it per cashier shift, and so on and so forth. So you might realize that you have those cycles. You might talk with your business, and they will tell you. Quite often they don't tell you because you don't ask, and for them it's such obvious things that those cycles exist that they are not talking even about that. And when you realize that, then you could have like accounting month close and accounting month open. And after that, you might realize that maybe you could break your streams, the huge account streams, into manageable accounting month streams. Then your aggregate or dynamic boundary would be the accounting month instead of account, right? And then each of the stream will start possibly with the same event type and end up with the specific event type. So simple as that. So then your record ID would build from the record ID, so for instance, account ID, and your life cycle ID. It doesn't have to be precisely the date or number. You might split it like a reservation, order, shipment, payment. That's also kind of like slicing the life cycle. And closing the books, of course we ignore it. We didn't tell that to Maurice. And even all of those patterns, anti-patterns that I told you, are actually not enough. Because people are still smart and they will try to fix that. So we need a better system. So Michael is responsible for that. So we will hire brilliant people, geniuses, because as I tell you, we will have a lot of money. They will be experienced, but in other tech stack. So like Maurice would be doing whole life Oracle development. Great candidate for our project, right? Maurice never saw even the streaming or even sourcing solutions. Great candidate. And we will tell them that, yeah, you can do it. And we will also use those principles like Edwards Deming, a bad system will beat a good person every time. We will use the Conway law, so we will structure our organization in that way that the communication structure will be so terrible that our system will be also terrible. And of course, we will be used SAFE. Actually, when I saw that for the first time, I thought that this is like a great pastiche of the management system. And do you know, I told you why Jira is called Jira. Do you know why SAFE is called SAFE? Because you will suffer. And yeah, we will use Jira. And luckily, we have Ross today. And we also use the platform engineering, and in the next edition, we will use what he told us. So what he told us, like, dump down, don't empower. And no platform users. This is a perfect scenario. We will spend a lot of time building platform without users. That's what we're going to do. Thanks, Ross. See, we are doing our homework already for the next edition. So in a nutshell, our management style is the fear, uncertainty, doubt. And if you think that when they quit, I would quit, no. Because we will give them a lot of money and we will use the Peter principle, which says that in a hierarchy, every employee tends to rise to his level of incompetence. That's why I'm not a manager anymore. In Poland, we have a saying that people are so busy that they are running with the empty wheel barrel. So that's another technique. And of course, I told you that we will be our events store. We will let them do whatever they want, as long as it's not trying to reach the proper way. So we'll pay them a lot. We will play with the fancy tech stack. And what if all of that won't be enough? Then we will hire a consultant. So I know that I'm a bit of time. I know that you want a beer, but TLDR. So it appeared that actually building the worst event sourcing system is not so simple, because it's easy to say that, this is, if the event source system are having issues with the consistency, with idempotency, events ordering, etc. But then people usually don't say like, okay, I was wrong. People usually say like, don't let internet dupe you. Your event sourcing is hard. Because it's hard if we are using the wrong tools for that, and if we are using wrong practices. So actually, as I told you, and as you know probably better than me, I'm just a humble developer working on the worst event sourcing system. So event sourcing is simple. We are just gathering user intention, and we are storing the business facts and making next decision based on them. We have the strong consistency. We do, right? We do. So it's not enough to just use the wrong stack, because smart people will eventually figure out. And usually those systems that fail are also using all the not matching tech stack. Like maybe you could use CRUD. You don't need to use everywhere event sourcing. And they are trying to complicate stuff with all these techniques and those practices that you might not need them. When they are helpful, but you might not need them. So don't try to complicate your system. Don't try to push your system to the limits. And you need to be really aligned. As Ross said, we are working on a socio-technical systems. So again, we need to invest in learning how to model those systems. Because if we're not, then of course we can say like people that are starting to work with document databases, how to do join. The neat trick is that you don't, right? And the same case is for event sourcing. You need to learn those modeling patterns to avoid those worst case scenarios. And shall you try to build the worst event sourcing system? I give you some hints. You already saw that we are already starting to prepare for the next year, because Allard will be a good candidate to beat us. But no, try us. We'll beat you again. And thank you. Yeah, this will install a rootkit on your mobile. Now it will take you to the blog article where there is a bit more about that stuff.
Thank you very much, Oskar. Let's give him one more hand.